Hello everyone, welcome back. And today we're doing this question called valid parenthesis, and it's rated easy, but it's actually one of the harder questions and um harder easy questions. Yeah, but it's easy if you know the data structure, which is stack. So a stack is basically a array-like item that you can add things to the back and remove things from the back in uh in O1 time complexity, and hence it's preferred for an operation that might be able to make use of this. So it's last in and last out, LILO. So this will come in quite handy for this question, and you will see in a bit. But yeah, let me explain this question now. So basically, you're given a string S containing just these characters, just opening and closing brackets of different types, curved, curly, and square. And we determine if the string is valid. So an input string is valid if the opening brackets are closed by the same type of brackets. So the openers have the same closers from the same family. And opening brackets must be closed in the correct order. They cannot be jump skipped, like opener must be closed in this order. It cannot be like this. And next thing is every closed bracket has a corresponding open bracket. So if we see a closing bracket at the start of the string, we know it's wrong already. We know this is wrong, this is correct. So where does stack come over here? Come into this picture. This is because the stack is able to keep things to the back, and every time we add, the latest thing comes to the top. And if we are popping something, only the latest thing gets popped out. We can use it for this kind of problems where if we add something and we add something, this will be the latest square. We need to find this square's closer now. So only if this exists, this is valid. If we see a curved bracket instead of a square bracket, and square is the latest item, we know this is invalid. In this case, it starts with a curve, then it's square. The square will be the latest item in the stack, and we see a closed stack. We check if these two are compatible, the latest one and this one are compatible. If it is, check mark, we delete the last item. We just remove them. The latest item in the stack will now be curved. The next item is also curved. Also works. So this works completely perfectly fine. So that's the sort of idea that we want to build towards. So let's jump straight to coding it out. We will first have a stack array, which will keep track of all the openers. This will just contain openers. And we will also have a brackets dictionary. A dictionary might seem like a bit of an overkill for this question, but it's only 3 items, so I don't mind using it for the convenience. Yeah. Okay, I need to make sure I don't make any careless mistakes because this part does seem a bit tricky. So curved. Okay, so curly, square, curved, curved. The benefit of a hash map is typically used when it's a large database to access from. But over here it's just 3 and it's an overkill, yeah, basically. Anyways, what we're going to do now is we're going to see each character in the string. For I in S, if I in bracket, that means if it is an opener, because the key in the bracket is all opening brackets. If I in bracket, it means it's opening. Whoops. If I in bracket, we just append it to stack. Else, we do something else. So if it's not opening, it is closing. That means if it is closing, we need to do something else. So what do? First thing that we need to check is if it is closing, we need to make sure there's something in the stack. Like if there's nothing in the stack, but there's a closing that we see, it'll be like this kind of condition. It starts with a closing bracket. In that case, it's a violation. We terminate it. So we just need to check if stack exists. So if length stack lesser than 1, That means 0 or something. And we can just check 0, I guess. But basically, if it is non-existent, we return false. Another thing that we can check is how do we delete from the stack? We delete from the stack only if it's corresponding with each other. So if I is equal to the stacks, like the whatever is the last item in stack, the last item will be an opener because the stack only contains openers. So if the closing item is the same as the corresponding opener's closer, I guess that's a bit of a tongue twister. Like it's a bit hard to say. Yep. So this is the opener. Using the bracket, we find the corresponding closer. Like if it's this, we find this. And if the closer over here and the closer over here are the same, we can reject, we can like neutralize the last item in stack, because the last item as seen over here has found its match. It's like happily married or something like. So yeah, we just pop that. Now, this is where the next part is. What if it's not the same? That means if this closer found an opener that has a different corresponding closer to this, that means it's a violation. So we just return false. Return false. And we, at the end of the day, we just return if stack is still present or not. So length of stack is equal to 0. Because at the end of the day, if it's perfect, if it's like a valid thing, every opener would have a closer, every opener that's seen would have been closed and neutralized away. Stack should have been popped away. It should be 0. Like the length of stack should be 0. So if length of stack is anything other than 0, we just return false. If it is 0, that means it's true. We have seen all of it. It didn't fail anywhere else. And if it didn't fail here, it means it's most likely a valid string. So maybe I should just check if my answer is correct as well. I don't want to keep talking and realize it's a wrong answer. So it works in all the different test cases. Let's submit. Okay, so our runtime is okay. Memory is also okay. I would say this could be maybe perhaps be optimized because a dictionary is known to take more space than usual. But yeah, I think in terms of time complexity, we perform this in n time complexity because we're only seeing each item just once and we don't traverse back and forth in any other way. And worst case, for the memory space, it's constant. Like we don't create anything for this array, but we might be creating more for this array. So at the worst case, every item in S is a open bracket without any closed bracket. That means everything will go to the stack. So hence memory will be n space, while time complexity will also be n because we're only seeing every item just once. And that's about it. So yeah, hope you guys enjoyed this video and I will see you guys in the next one. Do let me know if you have any feedback or anything that was unclear, and I will make sure to revisit or comment it in the comment section. Okay, see you guys. Thank you. Bye.